We are going to look at the difference of two squares concept and how it can help us to factorize expressions. To begin with, let's look at an example. We've got 4x minus 5 times 4x plus 5. Notice this is in the same form as this general statement above, where we have some term plus another term and then the same term minus another term. So let's expand out our numeric expression using FOIL. So FOIL means we multiply the firsts. 4x times 4x is 16x squared. Outsides, 4x times 5 or times positive 5 gives me positive 20x. Insides, negative 5 times 4x will give me negative 20x. And lasts, negative 5 times positive 5 gives me negative 25. As usual, after you apply FOIL, look at your expanded expression and see if you can simplify. I have two like terms, 20x minus 20x. Well, 20 minus 20 is just 0. So therefore, my whole expression expands to 16x squared minus 25. Now, what we can say in general, according to the difference of two squares rule, whenever we have an equation in the form a plus b, a minus b, it will expand out to the first term, a squared, minus the second term, b squared. Let's have a look at how we can apply this law to help us factorize. Okay. So here I've got a sum. It should say x squared minus 9x. So let's just fix that up. There we go. And it's in that expanded form of sum a squared minus b squared. In this case, a squared is x squared and b squared is 9. So if I want to turn this back into its factorized form, all I have to do is figure out what is a and what is b. Well, right now I know a squared is x squared. So to find just a, all I have to do is square root. Square root of x squared is just x. Again, I know b squared is 9. So if I want to find just b, I have to square root. Square root of 9 is 3. Now I can factorize. Factorized form is whatever a is plus b. So a is x plus b is 3. And then a, so a is x, minus whatever b is, 3. Let's have a look at solving this again with some clearer steps. Here my expression is y squared minus 49. My first step says take out any common factors. Now that only applies when you've got a number in front of your variable squared. You might have to take that out. And we're going to skip that step here because we don't have any number in front of y squared. Next, we have to square root each term to find a and b. Well, first, let's just define what a squared is and what b squared is. A squared is y squared and b squared is 49. Don't worry about that minus in the middle. So if I want to find just a, I'm going to square root y squared and that'll give me just y. And if I want to find b, I need to square root 49 and that will give me 7. Hence, to factorize my expression, it's going to be a plus b, a minus b. Well, a is y, so y is going to sit at the front of both of these, and b is 7. So 7 is going to sit at the end, and it's a plus b, a minus b. Okay, let's have a go at the next question. So take out any common factors. Here I can see I've got a term in front of my x squared. So I would take that out if I could, but notice that 4 is not a factor of 9, so it's not going to help to take that out. So instead, I'm just going to skip to my next step, which is where I'm going to define a squared and b squared to find a and b. Here, a squared is 4x squared, and b squared is 9. So if I want to find just a, I have to square root this whole term. So I'm going to square root the 4, which gives me 2, and square root the x squared, which gives me x. Again, to find b, I have to square root. Square root of 9 is 3. And now I'm going to write it in my form of a plus b, a minus b. Well, a is 2x, and I'll write that in the second one, and b is 3. And then I simply write a plus b, a minus b. Let's have a go at another example. Take out any common factors. I can see at the front here I've got 64 and 25. Now neither of those have any common factors, so I can't take out any common factors. I'll move straight to the second step. I'll define what a squared is so I can find a, and what b squared is so I can find b. A squared here is 64x squared, and b squared is 25y squared. So if I want to find just a, I need to square root both of these parts. The square root of 64 is 8, and the square root of x squared is x. I'm going to do the same to find b. The square root of 25 is 5, and the square root of y squared is y. I'll just write square root here so I know what my working out was. Now let's write it in factorized form. So we write a plus b, a minus b. In this case, a is 8x, so I'll write that at the front of both of my brackets, and b is 5y. So I'll write that at the end, and it's going to be a plus b, a minus b. Okay, one more example. Let's move through our steps. Take out any common factors, 12 and 27. Finally, we have a common factor. 12 and 27 both have a common factor of 3. So I'm going to take that out first, and then I'm just going to rewrite my expression and deal with steps 2 and 3 next after I've rewritten it. So I'll take my 3 out the front, and then I'm just going to factorize. So 3 times 4 is 12, and I put my x squared on the end, minus 3 times 9 is 27, and I put my y squared on the end. Good. Now, I'm just going to deal with what's inside the brackets here. That 3 at the front is going to stay at the front of my whole expression now. So in this case, a squared is 4x squared, and b squared is 9y squared. So I know what a squared is, so to find a, I have to square root all of that. Square root of 4 is 2, square root of x squared is x. I'm going to do that again to find my b. So I have to square root. Square root of 9 is 3, and the square root of y squared is y. Now let's write this out in our factorized form. Just do a little arrow down here so you can see it. So as I said, 3 is just going to sit at the front of our expression now, and then we're going to rewrite in our factorized form of a plus b, a minus b. A was 2x, so we write that at the front of both of our brackets, and b is 3y, so I write that at the end, and it's always a plus b, a minus b.